Hey, it's Mr. Z, and today we're going to go ahead and look at 2.3. We're going to determine multiple transformations of polynomials. The idea behind this is that you're going to kind of generalize some of the transformations, and then we are going to go ahead and figure out the specifics. So looking at part A, you can see that on the left we have our starting function. It's f of x, it's labeled, and then over on the right, we have the second one, the image, which is the translated function. And we're going to look at a couple specific bits. I always like to start with the center because this is how we graph. We look at the origin. And on the left, you can see that it's 0, 0. Here on the right, notice how it's 0, negative 4. So we know that the graph shifted down 4 units. We were able to get that from this part. We were comparing the outputs, and it went down 4. So we know that whatever we're going to do to the function, it's going to be minus 4. We also have to see how did 2/8 become 2/20. Now, it didn't shift left or right at all. How do you turn an 8 into a 20? Well, I have to remember that I'm minusing 4. I know that 8 times 3 is 24. And when I take away the 4, that's going to give me that same output. So basically the idea is that I want to dilate by 3. This is going to be the number in front. This is going to be the a value. The a value is going to be 3. So what do I do to f of x? I'm going to do 3 times f of x minus 4. I'm going to dilate it and then shift it down 4. Keynote when you're applying transformations, remember you do have to follow order of operations. The shift down 4 units, this is going to be addition and subtraction. All this dilate is going to be for multiplication and division. Let's go ahead and look at the next one. Here we see something that looks reflected, and it also looks wider. This is my original. This is my image. So let's go ahead and see what happens. In the center, we see that it's the same. Now, I am going to go ahead and look, and I notice that it is reflected over the y-axis. So the graph is here. It becomes over here. It's reflected over this is the x-axis. So which reflection is it going to be? Is it going to be negative f of x, or is it going to be f of negative x? It's one of them. Okay, I have to remember, well, it's the y's that's on top, positive y, negative y. So I'm going to use this one to represent the reflection. I also see that this point, notice how only the output changes, only the y value changes. It gets divided by 16. So essentially what's happening is that it's being dilated by 1/16. It's going to be compressed. So let's go ahead and write this out. It is going to be negative 1/16 of f of x. All right, g of x is very similar. Remember, look at the center. Well, it's clear that from the pre-image to the image, it's being reflected across the y-axis. It's over here, then it's over here. which means that the x's is what's being affected. So it's going to be f of negative x for sure. Looking at my center point, 2, 0, negative 3, 0. It's supposed to be negative 2 when it's reflected. So that means that the graph was moved 1 to the left. Now I have to figure out, okay, I know it's going to be an x change. So it's going to be on the inside. So my function is going to transform by the following. F of negative x minus 1. Okay. For 2, we're going to do the opposite. We're going to describe what the heck is going on. So from P to T, we know that the whole graph was vertically compressed. I know it's a half because 0.5 is a half. I also know that a negative x, okay, I look at it. Negative x's are here, x's are here. It's going to be a reflection over the y-axis. It's going to be reflected over the y-axis, while the x's are what's being changed. So I know that it's going to be a reflection y-axis. And that's the two parts. Here for B. Notice the 2 is on the outside, so it's going to be similar. Instead of being compressed, it's going to be a stretch. It's a vertical stretch by 2. It's doubled. Now, what is happening here on the inside? X plus 3. So the idea is if I had a line, and we're going to say the most simple line that's ever produced, a 1-to-1 line. It starts at 0, 0, goes 1, 1, goes 2, 2, 3, 3, and so on. Use this as a base to help prove your points. My x value is 0, and the output is 0. So this point is 0, 0. What would happen if I added 3? Well, you can see here that at 3, 3, that's the point. So essentially what it does is it adds 3. It's going to cause the graph to go to the left 3 so that it looks like so. It is a horizontal translation. By negative 3. If you want to also, if you like it algebraically, t of x, you could almost think of it as x minus minus 3. Whenever it's written on it, you can kind of instantly see, oh, it's the left 3. Whatever gets you to the end point. So I anticipate, go ahead and play with C and list out what each part does. What does this negative do? What does the negative 2 on the inside do compared with the outside? What can also help you to make sure you got it is the Desmos.